Good evening, ladies and gentlemen. Today's skill or lesson is on borrowing. It's not in our SWON, but it's something that's going to be important for you to be successful with the algorithm. So our goal is today I will learn how to borrow so I can use the algorithm in subtracting fractions. So our last few lessons have been using the area model, which is great. It's a great strategy, but it's not a very efficient strategy if your numbers are really large. Okay, we don't have any vocab, but we do have some notes. This is really important to understand. Fractions that are equal to 1. There is an infinite amount of fractions equal to 1, and hopefully you'll see a pattern soon. 3/3 is equal to 1. And the reason that is because what this means is I had a whole. It was cut into 3 pieces. That's what the denominator tells me. And the numerator means I have all 3 pieces. So that is the same as 1 whole. Another one is 4/4. That's also equal to 1 because again, it means the denominator tells me it was cut into 4 pieces. And the numerator says I have all 4 pieces, which means I have the whole thing. Okay, let's try another one. What if it said 6/6? That's also equal to 1 whole because it means the whole was cut into 6 pieces. And the numerator means I have all 6. So hopefully you're seeing a pattern here. And hopefully you kind of figured it out. Any fraction is equal to 1 as long as the numerator and denominator are the same. So that's why there's an infinite amount. We could say 10/10 equals 1. We could say 12/12, equals 1. We could say even 100/100 equals 1. So any fraction with the same numerator and denominator is worth 1. Okay, that's going to be really important to understand for this lesson. So our steps today are pretty short. We're going to take 1 away from the whole. We're going to turn that 1 into a fraction that is equal to 1. And then we're going to rewrite adding the fractions. Okay, so this again is not really a lesson, it's just learning a little skill that's going to help us when we get to a problem. Okay, so let me kind of show you what this means. So if I have, this is 2 1/5. Okay. Now the reason I might need to borrow is say this was my problem. If my problem was 2 1/5, take away 1 3/5, and I went to subtract, if I had 1/5, I can't take away 3/5. I can't do that. That's impossible. So I'm going to need to borrow. So the way I'm going to borrow is I'm going to look at my steps again. My steps say I'm going to take 1 from the whole. Okay, so if I take 1 away from this 2, it becomes a 1. Okay, then turn the 1 into a fraction that's equal to 1. So this 1 I just took away, I want to make it a fraction. Well, I always want to use the denominator I'm using. So because this is fifths, I'm going to say 5/5 because the 1 I took away is worth 5/5. So it's kind of like that regrouping. I took that 1 away and I cut it up just like I did with the area model. Okay, then it says I'm going to rewrite adding the fractions. So what do I really have? Well, now I have 1 whole and I have 1/5 plus 5/5 is 6/5. So this is the same as this. What I've done is just cut up 1 and I've regrouped kind of, or borrowed. Okay, let's try another one. So this says 15 3/8. So again, there might be a problem in the future that says 15 3/8 take away 7 7/8. Well, when I go to do this and I have 3/8 take away 7/8, that's going to be impossible. I won't have enough to take this away. So I'm going to need to borrow. So my first step says I'm going to take 1 away from the whole. Well, if I take 1 from 15, it becomes 14. And then I'm going to turn that 1 into a fraction that's equal to 1. So the 1 I took away, I'm really cutting it up, and I'm always going to base it on my denominator. So this 1 I took away, I'm going to rewrite it as 8/8. It's still 1, it's just cut up now. And my last step is I'm going to rewrite adding the fractions. So this is 14 3/8 plus 8/8 is 11/8. And that would be how I would borrow. Okay, so today we're not really worried about the algorithm yet. We're just learning this one part, so it'll be easier when we do the algorithm. Okay, so let's try some together. Okay, so my first one, I'm going to zoom in a bit. My first one says 3 1/3. And you know I don't like them written that way, so I'm going to rewrite it. 3 1/3. Okay, so I'm going to take 1 from the whole. So this 3 becomes a 2. I'm going to turn that 1 into a fraction that's worth 1. I'm just going to take that 1 and cut it up. So because this is a 3, I'm going to turn it into 3/3. And then I'm just going to rewrite adding it. So what is this equal to? It's equal to 2 1/3 plus 3/3 is 4/3. And that would be my answer. Okay, let's try another one. So my problem says 12 3/5. Okay, so I'm going to take 1 away from the whole. So my 12 becomes an 11. And I'm going to cut it up or regroup it into a fraction that's worth 1. So because this has a 5, I'm going to stick with it. So 5/5 is the same as 1. Then I'm going to rewrite adding my fractions. So I have 11 wholes, and 3/5 plus 5/5 is 8/5. Okay, let's try the next one. Okay, I have 1 6/10. Okay, so I'm going to take 1 away from the whole, which my 1 becomes a 0. I'm going to rewrite that 1 as a fraction that's worth 1, and I'm going to use this denominator to guide me. So this one, I could write the 0 or I could just skip it. I have 6/10 plus 10/10 is 16/10. Okay, my last one says 5 2/7. Okay, so we take 1 from the whole. My 5 becomes a 4. I turn that 1 that I took away into a fraction that's worth 1. So because of the 7, I'm going to use 7/7. And I get 4 9/7. Okay, so again, remember, this is just a step that we're going to be using when we do the algorithm. Okay, your homework tonight is 4 problems. Hopefully they go fairly quick for you, and please rate your understanding, and we will be practicing this tomorrow. Have a nice night.